A Rework for Rebar, The Tyndall Corporation, by
Liz Remark,
Maddie Money,
John Pastorani,
Ross Osborne,
and Joe Marchi. Our project took us to Spartanburg, South Carolina, home of the Tyndall Corporation. Tyndall Corporation is a company that specializes in concrete products. Their pre-stressed concrete is a popular product and requires rebar reinforcement to increase its yield strength and durability. Tyndall has a bar bending machine to help meet this need. However, there's a new bar bending machine on the market, pictured here. This new model will make the bar bending process more efficient and reduce labor hours spent by employees that manually bend the rebar on the old machine. Tyndall wants to bring this new bar bending machine into their facility, but the old bar bending machine must be kept to handle the specialty bars. Our objective is to devise a layout that will efficiently satisfy the need to keep both machines in operation.
There are two possible layout options that we will be considering for this project. The first alternative is moving the new machine to the available space outside of the facility. The machine is weather resistant and will be able to bend bars outside, which can then be put on carts and taken to the beds. Our second option would be to move the current operation to a new location that fits both machines. After speaking with Tyndall representatives, we know that they do have an open facility nearby that could be used for this purpose. We will be evaluating each of our new layouts by incorporating several factors, the first of which is the cost of labor. How will our employee hours change with each layout? Our second metric is the material handling. How will each layout change the amount of material handling from start to finish, evaluating both flow and distance? Utilizing these factors, we will then rate the overall efficiency of each layout through the craft method, minimizing the value of flow times cost times distance. Our data was provided by everyone's favorite Tyndall representatives, Mark Adams and Mackenzie Calquist. Mark and Mackenzie sent us data on the amount of bars processed, the amount of each type of bar, the flow through the facility, and the current facility layout.
Pictured here is the current layout of the facility. The flow process starts with delivery of the rebar and is immediately stored in the rebar racks. The next stop is the rebar shear, which cuts the 40-foot rebar into smaller pieces specified by the steel shop cards. From the rebar shear, rebar that will be bent is moved directly to the rebar bender. The straight cut rebar from the shear will be placed on its appropriate casting bed cart. After the rebar is bent to its specifications, it will also be placed on the appropriate casting bed cart, which then travels over to the welding booths. When the cart is done being processed at the welding booth, it will be placed near the exit door in the front of the steel shop, where a forklift will pick up the cart and take it to the finished cart area outside of the shop. Using our knowledge of the facility flow and material volumes, we created a from-to chart. We will use this chart to calculate the volume that will flow between stations and to aid us in using the spiral method of designing our new layout. For reference, we calculated the efficiency of our current layout from when the product enters the facility to when it's delivered to its final destination to be the total flow times the total distance times the total cost. This craft z-score came out to be 288.92.
Our first potential layout places the bar bending machine outside the facility, as shown here. With this new layout, we created a new from-to chart to use in our calculation of the craft z-score, as shown here. We calculated the efficiency rating of this layout and found that the only flow that changed was for 3 and 4 bent bars, which are the bars processed by the new machine. Using the same method as the current layout, we found that the craft z-score came out to 201.95. Our second potential layout had us move the entire operation to a nearby Tyndall facility. We were given the dimensions of the new facility by Mackenzie, and we used the spiral method to arrange our stations. The new machine was placed inside the facility. Upon calculating the Kraft z-score in a like manner of comparing the total flow times the total distance times the total cost, we obtained a Kraft z-value of 206.46. In summary, we calculated the Kraft z-score for each layout: current, alternative 1, and alternative 2. We will be concluding that the layout with the lowest z-score will be the most optimal layout based on having the lowest combination of flow times distance times cost. We found the current layout to have a z-score of 288.92, alternative 1 with the machine located outside to have a z-score of 201.95, and alternative 2 to relocate the entire bar bending process to a new facility to have a z-score of 206.46.
Comparing the two new layouts, we have to recommend moving the new machine outside of the current facility as a new layout for Tyndall Corporation. We believe that purchasing the new bar bending machine and locating it outside of the current facility is the best and most feasible choice because after calculations using the Kraft method, we found it has the most optimal z-score. In addition, implementing the new bar bending machine outside the facility would be the most practical and least disruptive option to the current operations. In conclusion, we would like to thank Mackenzie Calquist and the Tyndall Corporation for their assistance in our project. We could not have done it without their help.